Welcome back to the Mr. G Computer Science channel. If you haven't already done so, hit the subscribe button to get the latest updates and give me a thumbs up for the video. Today's topic is Boolean logic, so let's have a look at the details of the question. A drone is controlled by an app running on a phone. The drone has an auto land feature, which will automatically return to the takeoff point if certain conditions are met. There are three different inputs that the drone uses to determine whether the auto land feature is activated. And these are represented with letters A, B and C. So the first input is the battery level sensor. The input of a 1, which would indicate if the battery level is acceptable. An input of a 0 would show the battery level as being low. We also have a detector that tells us the drone is in flight. If the input is a 1, the drone is in flight. If the input is a 0, the drone is on the ground. Letter C represents the input of a connection wirelessly to the phone. An input of 1 would indicate that the drone is connected to the phone, and an input of 0 indicates the drone is not connected to the phone. The auto land feature will automatically land the drone when the level of the battery is low whilst it is in flight and is connected to the phone. Draw the logic diagram for the auto land feature. Now let's look at some notes that I've made on this exam question. First of all, I have highlighted in red the conditions that would be required to land the drone automatically. So let's take the input A, which is the battery level sensor. If we look at our definition, it tells us that when the level of the battery is low, so we're looking for a low battery, so I've color coordinated that as red. That is the condition of the battery that we would require for the auto land. Let's look at flight detection. Whilst it is in flight, we are looking for a condition that the drone is in flight, so I've highlighted that in red. The final condition is the drone connected to the phone? And again, I've used red to highlight the condition that would be required for the auto land. If we now look at the values, so A has to be a 0, B has to be a 1, and C has to be a 1. So we are going to take the condition of A being a 0. So this is using a NOT gate. So not A would yield A as being value of 0. ANDed with B being a 1. The result of that equation would then be ANDed with C being a 1. So let's just take some time to look at that. So battery level is low, so this is the negation of A, so this indicates that A has to be a 0. The result of that negation of A has to be ANDed with B, so the drone is in flight, and the drone is connected to the phone wirelessly. This would yield Y being equal to a 1, which would activate the auto land feature. I find formulating this Boolean equation helps me draw the Boolean logic circuit. So let's now take some time to look at the Boolean circuit. Let's now look at the Boolean circuit derived from the Boolean equation. So remember, the first input of A is the battery level, and for the auto land facility to be activated, the battery level has to be low. Therefore A has to have the value of 0. Input B tells us if the drone is in flight. So therefore B has to have the value of 1. The final input, condition C, is that the drone is connected to the phone wirelessly. So C has to have the value of 1. In our description of the auto land feature, the drone will automatically land the drone when the level of the battery is low, so I've highlighted that in red, whilst it is in flight, so I've highlighted that in red, and connected to the phone. I've finally highlighted that in red. A has to be a 0, and B has to be a 1, and C has to be a 1. Because we need A to be a 0, we are going to use the inverter or the NOT gate. We are going to AND that result with B, and then we're finally going to AND that with the input of C to give us our final value of Q. So Q will be a 1 when A is a 0 and B is a 1 and C is a 1. Hope you enjoyed the video. Don't forget to subscribe to the channel and give me a thumbs up for the video.